we're gonna start this video with a new definition, and a very important one. It's the greatest common factor, or divisor, also called GCD or GCF if you say factor. So we have two integers, a and b, not both 0, and the GCD between a and b is gonna be the greatest among all the divisors a and b have in common. So the notation we're gonna be using is that the GCD between a and b is gonna be parentheses a, two dots, b. And what does it mean, being the greatest among all the divisors? Is that the GCD is going to divide a, and the GCD will divide b. And if d, an integer, divides a and d divides b, then d will be smaller than or equal to the GCD between a and b. So when we think about a few examples, the first one that comes in our minds is 1. 1 will divide a, and 1 divides b for every a and b integers. So this tells us that the GCD exists. It could be 1, or it could be any number d greater than 1, but it could be 1, so we know that it exists. For the same reason, -1 divides a, and -1 divides b for every a, b integers, and this tells us that the GCD between a and b is a positive number. Why? Well, because -1 is negative, but as we have -1, we have 1, and -1 is smaller to 1. Let's now think about another example. If we make a list with all the common divisors we have between 36 and 60, the list we get is 1, 2, 3, 4, 6, and finally 12. This is the list of all the divisors 36 and 60 have in common. So with this list, what we can conclude is that the greatest common divisor between 36 and 60 is 12, because it's the greatest among all the numbers in this list. Let's see now a few properties and examples. Some of these properties, most of them, will be left as exercises, as they are not very hard to check. The first one is very simple, is that the greatest divisor between a and b is the same as the one between b and a. And this comes straight out of the definition we just gave, so it's very simple. The second one says that the greatest common divisor between a and b is the same one as the one between -a and b, and the same between a and -b, the same as -a and -b, and it's gonna be the same as the absolute value of a and absolute value of b. The third property, the greatest common divisor between a and 0 is the absolute value of a. For every a that's an integer except the 0. The fourth property is that for every a and b integers b not 0, we have b divides a implies that the greatest common divisor between a and b is equal to b. Let's try and prove this. We're gonna start calling the greatest common divisor between a and b d. Using the definition, we know that d will divide a and d will divide b, because this is what we wrote right here. The common divisor between a and b divides a, and it also divides b. So now, if we take any other number d that is not the greatest common divisor, then d will be smaller than the GCD. So we know, because of our hypothesis, that b divides a. We also know that b divides b. So we have another number, b, that is different to our greatest common divisor, d. Then, using the definition, b is smaller than or equal to d. But now d divided b. So here we know that d is smaller than or equal to b. And now, combining these two ideas, the only option we have is that b is equal to d. And d was the greatest common divisor, so b will be equal to the greatest common divisor between a and b. We know how this exercise where we're given a number a, an integer, and we want to find what set will be containing our d. So for different values of a, we may get different values of d, where d equals the greatest common divisor between a squared plus 8 and a plus 1. In this case, we want to prove that this set is going to be 1, 3, and 9. So for different values of a, the common divisor will be either 1, 3, or 9. For this, let's look first at the possible common divisors between a squared plus 8 and a plus 1. Let's say I have a number d that will divide a plus 1. Then we know this number d will also divide a minus 1 times a plus 1, because this is just any constant c integer. And if we do this distribution, then we get that d will divide a squared minus 1. We also want to see what happens if d divides a squared plus 8. So if this is a common divisor between a plus 1 and a squared plus 8, then we saw in a previous video that when we had d divided x and d divided y, then d divided x minus y. If you haven't seen this video, I recommend you go and watch it. So d divides a plus 1 and a squared plus 8. So we have that d divides both a squared plus 8 and a squared minus 1. So d will divide a squared plus 8 minus a squared minus 1. This is a squared plus 8 minus a plus 1, a squared. And this equals 9. So d divides 9. D is also a positive number, and d divides 9. So this will give us only 3 possible values of d. I recommend you try and check which integers between 0 and 9 divide 9. If you do the math, you'll get that these 3 integers are 1, 3, and 9. These are 3 possible values for the number d, and d we defined it as the greatest common divisor between a squared plus 8 and a plus 1. However, d will only take one number. D cannot be 3 numbers at the same time. Different values of a will give us different values of d. Let's try this with a few examples. With the calculations we did before, we got that d is one of these 3 numbers and is the greatest common divisor between a squared plus 8 and a plus 1. Let's see now 3 examples where d will take these 3 values. So if we take a equals 0, d will be the greatest common divisor between 0 squared plus 8 and 0 plus 1. This is the greatest common divisor between 8 and 1, which is 1. If a equals 2, d will be the greatest common divisor between 2 squared plus 8 and 2 plus 1. This is the greatest common divisor between 12 and 3, and this number is 3. Finally, if a equals minus 1, remember that a was any integer, then d will be the greatest common divisor between minus 1 squared plus 8 and minus 1 plus 1, which is 9 and 0, and this greatest common divisor is 0.